modeling of the robot. So any kind of research, see, there are several kind of even school students are doing the robotics. There are entertainment robotic clubs, but what is if you think about the research point of robotics, so how we have to proceed. So hope most of the audience are from faculty from various colleges. Am I true?
Yes, sir. Yes, sir. Yes, sir.
With
Sir,
respect to
request, sir, wondering a small request. Can you hide that button, sir? I'm seeing. That's good, sir. Thank you,
because
sir.
huh,
Okay, sir.
see, most of us are faculty members, so we have to train our students towards the higher education and the research side. See, nowadays, even if a student become an engineer, scientist, or a teacher, they have to continue the this higher education. Otherwise, they won't get
That's
promotions.
good, sir. Thank you, sir.
So here,
Okay, sir.
see, this robotics club or school in schools also nowadays people are doing science fair. There is a separate robotics club. Even in engineering colleges, there are so many robotics clubs are there. Nowadays, even if that is different, and the research point of view is different. So if you are doing a research point of view, particularly this. Hello, are you with me? Hello.
Yes, sir. Visible. No, audible, sir. Yes, please proceed.
So if there is any internet connection, you might be having my phone number, right? So immediately.
Yes, sir. We have. We'll talk to you. No problem.
Okay.
Right.
Okay. So my concern is, can you please tell me? Please try to be interactive. Can you please tell me what kind of journals you are referring for this robotics topic? Which are the best journals in mechanical engineering or electrical engineering?
Participants, please.
So please try to be interactive.
Yeah, one of the journal is our International Journal of Robotic Research.
Okay. So mostly you are from mechanical background?
Yes, sir.
Okay. There is one journal name called as ASME. I think hope you might be
Yes,
referred this and ASME.
yes, sir. American Society for Mechanical Engineers.
That is a top class journal for this robotic research. Even if you take a part of the work from the ASME journals, that will be appreciated. If you take the electrical engineering, IEEE robotic, IEEE Ocean Engineering Society. So there are some societies. This particularly in IEEE, there are some societies. Those are non-profit entities. So if you do research in this area, particularly in this marine robotics, they are giving full funding. Like for example, if a full-time PhD student is doing research in marine robotics, if his paper is accepted in anywhere in across the globe, so full funding will be provided by IEEE. No need to take registration charges. No need to bear of your this transport, travel, DA, TA, everything they will sponsor. That is one of the important aspect here. If a person will do research in this robotics area. Next is modeling. So one has to understand first what is modeling. So without mathematical modeling, we cannot proceed, because if you want to do research on this land-based vehicles or aero vehicles, marine vehicles, the size is very high, cost is also very high. It is very difficult to spare if you think towards the educational point of view, as a student, faculty. So first we need to start with mathematical modeling. Then we have to analyze it. So if it is workout in any of the softwares like MATLAB, then we can go for the prototype design. So this is the outline of my presentation. So first is we'll start our discussion with marine robots, then land robots, then aero robots. Likewise, we'll go. So why we need to do this? Why we need to study underwater robots? Do you know where is the biggest DRDO lab of this Naval Research Board? Participants, can you please unmute and tell me where is the biggest DRDO lab of NRB, ARB?
One of them is at Vishakhapatnam, sir.
Very good. Naval Research Board is located in Vishakhapatnam. Next, ARB, Aeronautical Research Board. Aeronautical Research Board is in Hyderabad. You might be heard about RCA, DRDO RCA, Research Center Imarat. So both these labs are located nearby only. One is in Vishakhapatnam, another one is um, Hyderabad. So if you collaborate with some scientists, they used to give some kind of, they will release projects in terms of cars. Up to 20 lakhs, scientist F can provide this 20 lakhs research for the some kind of smart simulations, some kind of hardware in loop experiments. This is one advantage, because since we are near to this, if your work is appreciated or if your publications are good, they are ready to give the funding. See, as I told you, ocean 70% of the land is occupied by ocean, as we all knows. So oceans have been playing a very crucial role in the transportation of goods, aquaculture, offshore mining. So we need some kind of instrument is required to study about this oceans. So that instrument here considered as marine robotics. So marine robotics is a interdisciplinary research which involves engineering, computer science, environmental science, and oceanography. So even this the research labs working in this area are, one is a Naval Research Board. There is one CSIR lab called as NIO Goa, National Institute of Oceanography. So these autonomous underwater vehicles and remotely operated underwater vehicles are considered as marine robots. All, even the small kind of ships. So why this marine robotics are complex? The reason behind is marine vehicles are non-linear, multivariable, coupled, and unstable systems. See, non-linear means it is very difficult. Multivariables means multi-input, multi-output. Coupled means two or three variables are coupled to each other. Unstable system. That is the reason these marine robotic vehicles are very complex in nature. So we have to provide the solution for this. So how to provide the solution for this? So task is from the engineer point of view, what we have to do is we have to provide this navigation, guidance, and control system for the any kind of robot. So if you can able to provide this navigation, guidance, and control to the marine robots, so the trajectory will be easy. So there is one separate software available in the MATLAB that is called as GNC, Guidance, Navigation, and Control. So you can work once you download this MATLAB of this GNC portal. Next is trajectory tracking and control of vehicle is always challenging task in underwater environment, because underwater environment most of the sensors will not work. Only very few sensors will give proper information. So that is the reason always trajectory tracking is plays a key role. So motion control of marine robotics becomes interesting and challenging. The reason behind is in underwater environment, the dynamics will be different compared to aerodynamics. So first is navigation. So navigation, as we all know, so if you know this, the Google Map, from the Google Map, we will get navigation for the land-based vehicles. So for the underwater robots, there is a sensor called as IMU, inertial measurement unit. So using that IMU sensor, we can track the vehicle from the land. So some sensors are required since it is a 3D vehicle. So we need to have both the translational and rotational parts. So the navigation is done with the help of this computer control room. So the other way to represent this vehicle dynamics are, so all these robots, either it is a land robot, either it is a marine robot, or it is a aero robot. So rigid body is considered as a robot. So this M represents translational, IZ represents rotational. So here, since we considered this marine robot, these are hydrodynamic damping and added mass. So this is particularly for the marine robot. Since it is works in the water, so it has hydrodynamic damping. So you see here, XU dot XU norm of view. So all these are nonlinear terms. Fin lift. So if you want to move the vehicle, we need some kind of propeller. So propeller, thrust, and rudder angle are the inputs to the marine vehicle. So this is the combination of dynamics and kinematics. So this is one way of representing vehicle dynamics in terms of mathematical means. So observe this figure. So this pink line is called as actual orientation. Yellow color line is called as desired orientation. So this is the vehicle inside the water. So the gap between this pink line and yellow line is called as error signal. Simple control objective is drive the orientation. Error is equals to desired minus actual to 0. So here to reduce this error, we are applying lot of controls. Like, do you know what are the different types of control techniques? Participants?
PID control, model
PID.
predictive control, sliding mode control, adaptive control.
Okay, very good. So now people are talking about this artificial intelligence, machine learning, reinforcement learning, right?
Yes,
So,
sir.
Yes.
so whatever you told, those are um, core control techniques. Now people are asking computer control techniques. Computer control techniques in the sense all these machine learning, deep learning, reinforcement learning. So if you know simple PID control, you can understand any kind of control. So the main task, central idea behind this control system is we have to make this error as minimum as possible, if not zero. Clear? Now you see, this is a simple closed loop diagram. So this is vehicle. A vehicle is having sensors. So these are heading sensors. And the output of this system here is, what are the outputs of any vehicle? Can you please participate in discussion? What?
Speed, acceleration,
Ah,
velocity.
okay, very good. So all these are measured with the help of this sensor, particularly in the underwater environment. IMU sensor is used to measure all these speed, displacement, acceleration. Oh, in terms of this, particularly in marine vehicles, station keeping is called as the vehicle standing in the middle of the ocean. That is also one of the challenging tasks. That is called as displacement, where the ship is, where is the location of the ship. That is in terms of marine robotics, it is called as station keeping. Station keeping of the vehicle is a challenging task in marine environment because there is a lot of ocean waves, ocean winds. So that is one of the key challenge for control system engineer is how to make the vehicle in a station keeping. That is one. Another one is how to control the cruise speed. There are two things. When you apply the brake, the vehicle has to stop. When you accelerate the vehicle has to move. So this is called as these are the main two challenges of any vehicle, whether it is a aero vehicle, marine vehicle, or land vehicle. So those values are sensed here and given to. So here you see left hand side desired heading. So from right hand side measured heading. So if there is any error, that is called as heading error. That heading error goes to the computer plus control logic. Nowadays, most of the people are asking, do you have artificial intelligence based learning? Do you have deep learning? So all these programs, make? Can you please give an idea how to develop the controller here? If it is a laboratory model, how to develop the controller? What is a physical? If you want to make a physical controller, uh, what kind of device you use? See, this is yeah,
We can use LabVIEW and we can use DECMAX card. And we can implement our
no
logic.
hardware component. If you want to design PID control using hardware, so what kind of components are required?
Any motor controller. We need to control the motors operating the propeller or fins,
No, see,
rudder.
we are the output of this controller is 10 and rudder. But if you want to design some hardware in the computer control algorithm, how to make the this one?
So microcontroller we have to
Very
use.
good, very good, very good. So we have to use some Arduinos, right? So Arduinos are available from rupees 152 in terms of lakhs. So those Arduinos are interfaced to these computers. Then we are writing the program. So here, one important thing we have to observe is we are developing the control logic. So not the computers, computer engineers will make this control logic. They do not know the logic, control logic. So we have to develop the control logic, or we have to explain these are the inputs and these are the outputs. So then they will give the code. Now using this in internet, there are a lot of so resources are available now. Chat GPT, so many they will give automatically coding, but we must know what are the inputs and what are the outputs. So then only we can provide. So very good. So the hardware is we have to use Arduinos. If it is a big vehicle like Marine Robot or Aero Robot, they have separate high-speed processors are there. So using those high-speed processors, they develop this control logic. So output is 10 rudder.
Sir, I think
You
your presentation is not visible, I guess, and your video.
it's not
Sir, yes, sir. Your slide is not visible, sir.
share button. You're not
Maybe you can stop presenting and you can re-present, sir. That may work out, sir. Now visible, sir, your video.
now you see.
Yes, sir, yes, sir. Yes, sir. It is
Now it's
visible, sir.
visible, right? Okay.
Yes, sir. Yes,
Thank you, sir. Now it's fine.
Now can you please tell me this Sten and rudder? Where is the location of Sten and rudder?
Stern is at the rear end, sir, of the vehicle, of the boat.
Rear end. Okay. It means see down there is a vehicle, right? So the tail of the fish is nothing but rudder.
Okay.
Okay. So there are two sets of fins. So backside fins are called as stens. Okay.
Okay, sir.
So using these two, so these two are called as control surfaces. So we have to apply most of the controls are on rudder and stem. So how we swim with the help of legs and hands only, right? Leg movement and hand movement. So similar way, if we can apply controls over this stem and rudder, then we can control the vehicle. Okay, what are the other control techniques are speed, orientation, depth, altitude above the seabed. So this is called as the path, this is the vehicle, this is desired heading, this is actual heading, and this is the closest part of the point of the path. So we need to apply the control to minimize this actual and desired. So that is the goal of the. Okay, now can you please tell me what do you mean by guide and mentor?
Pardon, sir. Please repeat the question.
What is the difference between guide and mentor?
Mentor handholds the his mentee and takes him till he reaches his goal. Guide.
Sir, guide is the one which holds the product to be made, and the mentor is the person who directs. Actually, direction is given by the mentor, but does not hold.
Okay.
Thank you.
Okay.
Thank you, sir.
Thank you. Well, see, with respect to the robotics, I will give you one example. Suppose if you are moving from Tirupati railway station to bus stand. So if he is a mentor, he will say, I'm going from railway station to bus stand, you just follow me. So he's called as mentor. Guide means, so there are three paths to reach from railway station to bus stand. So you can, if there is a traffic, you can go this third line. If there is no traffic, you can go to the second line, or else you can also follow some other line. So guide give opportunities, like these are the resources for you. You can follow in any one path. Whereas mentor means I am going on the same route. You just follow me. Got my point?
Yes.
Huh.
Yes, sir. Yes, sir.
So here also we are also guiding some students, so we should not provide everything to them. So first we have to allow them to search in different directions. For a problem there are n number of ways to find out the solution, but the solution should be unique. Okay, so please if you are using, how many of you are using MATLAB participants? Are you with
Yes,
me?
sir. We are
Okay.
using, yes.
Okay.
Yes, sir. Yes, sir.
There is a there is separate toolbox, like MPC toolbox, like guidance navigation control toolbox is also available. So you can work on this guidance navigation and control toolbox to identify the problems related to the control engineering, and also you can define the trajectory path. When this ISRO scientist launches the missiles, in the television we used to see the missile movement. The same way we can analyze with the help of this guidance control navigation in MATLAB. So this is navigation. See, this is vehicle. So these three plays very important role to reach from one place to another place. So one is navigation. So nowadays, driving a car inside Delhi, Bombay, Hyderabad is a challenging task. So one must know this Google Map knowledge. Driver must know Google Map knowledge. Otherwise, he cannot drive inside the Delhi, inside the Bombay, or inside any metropolitan cities. Next is guidance. So from the available path, which is the best path we have to choose. Next is apply control. Control means he has to apply this. He should have some experience. Then only he can drive the vehicle properly. So that's a common idea for any vehicle. Now you see these are some of the examples of marine robots. So this is single robot. These are multiple robots. This is a robot carrying some payload. This is one research vehicle. This is surface vehicle. So this robots modeling, particularly this is a rigid body is considered as a marine robot here, and this is earth fixed frame or inertial fixed frame. So we are at the ground and the vehicle is in the water. So how to analyze this vehicle using mathematical means? So U is defined as inertial reference frame, B is defined as body reference frame. So this V1 and V2 are linear velocities. V2 is rotational velocities with respect to body and earth fixed frame. So if you want to monitor your vehicle from the control station, which is at ground, so we need to look at the question mark. So what will be the question mark? Can you guess and tell me how we can monitor the vehicle from ground station to this water or air?
It is how far it is display position vector. You may be referring to position vector.
Very good. Hey, what is the question mark? In question mark, what would be? Can you guess?
XYZ coordinates of the robot of the
What kind
boat.
of mathematical tool?
Rotational matrix, transformation matrix.
Very good, very good. Rotational matrix is required. Rotational matrix is required. That is RUB, means inertial frame and body fixed frame. Okay, you are correct. So all these underwater vehicles have to satisfy one condition, that is called as R transpose is equals to R power minus 1. So this is called as, what is the name of this property? Any idea?
Optical property.
Huh? R transpose is equals to R power minus 1.
Symmetric. Symmetric.
Skew symmetric. Skew symmetric. Very good. So some nomenclature is required to understand these vehicles. Those are psi is equals to yaw, theta is equals to pitch, phi is equals to roll. So using Euler angles, we can analyze this roll moment, pitch moment, and yaw moment. Now you observe here, this is XYZ axis. In mathematics, we used to call it XYZ axis. This is RX, RY, RZ. So first matrix you see, one is fixed. It means X axis is fixed. The vehicle is moving in the Y and Z directions. That is having the Y is and Z are having angles. Similarly, RY is Y axis is fixed. X and Z are changing. RZ is Z is fixed. X and Y are changing. So with respect to the body, the same thing is denoted here. C stands for cos theta, S stands for sin theta. One is fixed and both are moving. So this is with respect to body. So those who are doing in this research, there is a very standard, high standard book is there. Please note down, Guidance and Control by T.I. Fawson. So this is like Bhagavad Gita who are doing research in marine robotics. Please note down, Guidance and Control by T.I. Fawson. So this is called as transformation matrix. So these are the nomenclature of underwater vehicles. U stands for surge. Surge means forward speed, forward and backward of the vehicle. V means sideways, right side, left side. Heave means up, down. P is the roll rate, Q is the pitch rate, R is the yaw rate, and these are the velocities V1 and V2. These are the displacements X, Y, Z. In the linear, theta, phi, theta, psi are the rotational moments. So this is the standard convention which is taken from this book, Guidance and Control by T.I. Fawson. You can observe these axes, X, Y, Z axis. So X axis is forward speed, forward or backward. Y axis is sideways, right side, left side, which gives the pitching moment. X axis will gives the rolling and surge movement, and Z axis is yaw and heave. So these are the first three equations are called as translational, and second three equations are called as rotational. Those are torques. So this nomenclature is very important. So this is a standard matrix vectorial form for the marine robotics. So this is simple. F is equals to ma, not more than that. So right hand side is F, that is tau, that is applied torque, which will come from the propeller. Tau wind. Tau wind is called as the disturbance. Tau wave is also one kind of disturbance. M is the mass of the vehicle. C is the corollaries. D is the damping. G and G naught are the acceleration due to gravity. So here the control designer has to focus on only this applied torque, and he has to minimize this tau wind and tau wave. So this is one example taken, that is siren. So new 1, new 2, V1, V2, these are translationals and rotational. Kinematics. What is the difference between dynamics and kinematics? Can anyone tell me?
Motion under the application of force or torque, that is dynamics.
Very good. Kinematics.
Kinematics, that is under initial condition without any application of force or torque.
Okay. Okay, good. What you mean to say is if there is no input, that is called as kinematic. If there is an input, it is called as a dynamics.
Dynamics, yeah, right.
Okay. Now you see these are Newton laws, nothing but Newton laws. F is equals to ma. As I told you, so this is F. Sum means summation of different forces, or in the sense we can say different torques. So these are the translational forces. Translation F is equals to m into a. D by dt of v means this is a, acceleration. M stands for mass. F u rb. U means earth fixed frame. Rb means rigid body. Some of the external forces. So though this equation looks complex, but once you understand, it is very interesting and easy. These are the dynamics with respect to translational motions, and these are with respect to the rotational. You see now n stands for this rotational moment. These are the dynamics. Dynamical equations, kinematic equations, and these are external torques, external forces measured with respect to the body. Now you try to understand again this right hand side. First you look at the right hand side. X, Y, Z are translational. K, M, N are rotational. These are torques, these are forces. F is equals to left hand side is MA. So this entire equation is nothing but MA. So here V into R, W into Q, U into R, V into P, these are coupled. When you are applying a control, you can decouple and apply, that you can get some benefits. So why it is called as non-linear multi-input multi-output coupled dynamical system is these are coupled. QR is coupled here. R square Q square, this is non-linear. Likewise, so a lot of complexity is there. Kinematics, these are rotational matrices. Again the same. We'll skip some part. See, this is tau RB. Tau RB is summation of tau plus tau A plus tau D plus tau R plus tau disturbance. So tau is control input. So our main focus is this tau. So we have to design the controller. That controller should respond with respect to this tau only, and it should minimize this tau A, tau D, tau R, and tau disturbance. What is tau A? Terms due to added mass. Tau D is hydrodynamic terms due to lift, drag, skin friction. Tau R is restoring forces and torques due to the internal play between gravity and buoyancy forces. Tau disturbances terms due to the external disturbances, waves, winds. See, imagine when you are operating any marine vehicle in ocean or in any sea or any river, there are a lot of disturbances like waves, ocean currents, ocean winds. So all these disturbances should be minimized so that the control engineer will play a major role. So these are with respect to the stability. This is F buoyant, F gravity. F buoyant is less than F gravity, then it sinks. F buoyant is greater than F gravity, then it floats. So negatively buoyant, this is the condition. Positively buoyant, both the B and W are same. Neutrally buoyant. Did you heard about what is added mass? Participants?
It can be any payload which is added to the rigid body.
Yes. When a vehicle is enter in the water, so water will also fall on the water. So there may be a weight increase or weight decrease. So that is considered as added mass.
Okay, sir.
Hydrodynamic terms. So these are considered as hydrodynamic terms. So hydrodynamic terms is very challenging task which consists of so many nonlinear components. You see the yellow one, highlighted one, diagonal of xu of u, this norm of u. So all these are nonlinear terms. So we have to linearize it and then apply the control, or else we have to use nonlinear control, because what is square root into square root 2? Square root 2 of into square root of 2 is equals to 1. So if the system is nonlinear, and if you apply nonlinear control, then the resultant is linear. So if the system is nonlinear, you have to apply sliding mode control or adaptive control. So then only the resultant will be the significant, you will get significant results. Otherwise, if you apply linear control or nonlinear vehicle, there is no result. That is, concept itself is wrong. Some of the students will do like they apply PID control on nonlinear system. In MATLAB it may work, but in the real time it won't work.
It may be works around operating condition, maybe if there is a fixed operating condition. Linear control may work.
No, linear control is applicable only for the linear model. If you apply it on the nonlinear model, how it will work? Even if you consider operating regions also, if the system itself is nonlinear, how you can apply linear control?
Maybe we can linearize it and then.
First we have to linearize it. Then see, if a person is suffering from fever, first we have to diagnose it, and then we have to give the medicine, right?
Right.
First we have to understand the vehicle dynamics, whether it is nonlinear or a linear. Accordingly, we have to give the correct prescription, like which control is the best control for that model. So M means MRB plus MA, that is actual rigid body mass plus added mass. So first equation is called as dynamical equation. Second equation is called as kinematic equation. So
Sir, I have one question on it. Can I?
Yes,
Okay,
please.
sir. As you said, for linear model, we can't apply linear controller, right?
Yes, nonlinear model.
If suppose that a linear controller has capability of robustness, like H infinity, if you go ahead with that, okay. So H infinity will be a suitable for that in that case.
H infinity?
Controller. We
H
can
infinity.
apply for non-linear, right? As well as in linear case also.
No. H infinity, how you can apply for nonlinear?
Okay, so H infinity non-linear controller is there, right?
The non-linear H infinity you can apply, but H infinity alone, how you can apply?
Sir, there are many proven track record for H infinity, sir, for experimental analysis also, and they have proven through that one. For example, if you refer a National Institute of Ocean, Goa, okay, Professor Moria and
Pramod Moria, I know Pramod Moria.
yes, sir. Yes, sir.
Yeah,
Okay,
tell me.
so their work and their Maya vehicle is totally based on that
See, Maya
controller.
vehicle. They linearize the model.
Yes, 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 sir.
The
But
actual vehicle is the non-linear only. So for the study purpose, which is available on the internet, or they publish the paper, so those are all linear models only. You are talking about Maya vehicle?
yes, sir. Actually,
That is
okay.
India
So
made.
in my
Their own inbuilt vehicle.
they built one more. They built. There are two vehicles now with them in
Maya and
Maya, and one more is there, sir. Is they specifically used for the coral reef detection, sir.
Coral Reef.
Uh,
Okay.
yes, sir.
Coral Reef also it is linear only. I think one of my MTech student worked there in NIO Goa only.
So actually, what they did it, actually they use the non-linear model only, sir,
Okay.
and they are uh, approximating that domain, sir, a specific point,
Okay.
and they are applying the linear controller over there simply, sir. And whenever that bound will reach, and they will control over this.
Okay.
And all their testings are based on the ponds only, sir.
They have
They have
their
their
own
they
their
have
own
their own pond,
research
okay,
facility.
and
I have
specific
visited two,
coastal
three times.
yes, yes, and they have their own coastal areas, sir. They will trial over there,
Okay. So
and
what your concern is H infinity can directly apply on non-linear
actually,
systems.
Yes, sir. Linear as well as in non-linear, sir. Actually, if you bring about one of the co-author of that Maya vehicle or the is Antonio Pascal, right? His
This work
very
also.
old paper. His work
They
also
work,
dedicated to that. Okay.
hmm.
His work since 1980 onwards, sir, along with the Fosen and all those things. They
He's a
already
student.
put to
Pramod Maurya is a student of Pascal only.
yes, Pascal only, sir. Okay. Actually, they published their work long back, sir. In the I think so. I referred their work in 88 onwards. They applied H infinity controller for that, sir. Very good paper for them also. Through experimental analysis, also they presented over there.
No, it is good point which I have really considered from your end. Uh, so what you are saying is at
Sir,
some
actually,
different operating
uh,
conditions, we can apply
some
linear.
different. Yes, sir. Actually, that some linear controller has that adaptability or robustness
Like
capability in
operating
certain
conditions,
range. Huh. Yes, at a
only in
tuning
certain
or
range.
adapt
See,
certain range.
see what literature survey is saying is
Hmm.
instead of applying linear control to non-linear system, better if you apply. So that is the reason case to case it will work. So
Yes, yes,
for some vehicles it may work, for some
hmm.
vehicles it may not work. So that is the
Yes,
reason most of the applications, if you refer, this mostly the sliding mode control is used for the nonlinear systems, right?
yes, sir. In addition to that, many are there, sir. No, okay. So nowadays within India and outside, for because of simplicity, SMC we can go ahead with that.
Hmm.
Yes, okay. Because
The-
in addition to that,
Okay, okay, leave it. My concern here is uh, this depending on case to case and vehicle to vehicle, some controllers will shoot, right?
yes, correct.
So according to that, so first we try for with respect to this
Yes,
even MPC. Some participants are raised that MPC can be used.
yes, yes,
So in
yes, yes.
MPC also, in model predictive also control also, there are non-linear model predictive controls also available.
Are there?
So
Yes, yes, yes.
we can go for the non-linear model predictive control to non-linear vehicles instead of linearizing, because when you are non-linearized, when you make non-linear to linear, some of the terms will be missing. So actual model we cannot predict from non-linear to linear, right? Clear?
I agree, sir. The stability will confirm under specific region only.
Hmm.
Out of that region, it won't give the satisfactory response. You are right. So non-linear controller are more better.
See, the this person name is Corollaris. So he is one of the dangerous person in the field of particularly this nonlinear. Corollaris and centripetal forces. These are important terms in the marine robotic field. These are the control inputs. So where we have to apply the control? Basically on the propeller. So look at the first figure. This is, we have to apply the control on propeller. One is rudder, another one is stem. These are control surfaces. This is airfoil. So this is applicable for marine aero vehicles. So you look at there are two parts. One is upper part and the lower part. So when you apply here this, then the travel distance between the lower part and upper part is high. So that's what there we get angle of attack. So as I said, the control surfaces are, one is rudder, stern plane, and this front one, the rightmost is called as bow plane. These are the thrusters. Effect of currents. So there are different regions for the disturbances. So if you measure this area 0 meters and minus 10 meters, minus 500 meters, this is a deep sea research. Deep sea research is done in minus 500 meters. So now most of the research is going on in this deep sea research. This is AUV model, so one can easily understand from here. It is the rudder is the backside, and this is stem plane, and the starting one is bow plane. So these are the values. Those who are the beginners, you can consider these values for the simulation purpose, MATLAB simulation purpose, infant AUV. So this I have taken from Antina Pascal, as you mentioned. Na? This I have taken from Antina Pascal. These values, you take these values and simulate that. That gives you some strength in mathematical modeling. So, in a nutshell, what I am giving is this model means mathematical model of marine robot dynamics. So, which consists of dynamics and kinematics. Left hand sides are inputs, right hand sides are outputs. So, control system engineer needs this is the base thing, that is mathematical model of marine robotics. What are the inputs? As we discussed, 10 plane, rudder, bow plane, throttle. What are the disturbances are vehicle conditions. The aging of the vehicle also matters, and the other disturbances are ocean currents and ocean waves. So if you find output with respect to the input, it is called as servo control. If you find output with respect to vehicle condition, it is called as regulatory control. If you find output with respect to disturbance, it is also called as regulatory control. So challenging task is not servo control. See, if you apply control on these surfaces, automatically the vehicle will move in the right direction. But at different vehicle conditions and different kind of disturbances, how your vehicle is responding. So for that, the control logic is important. Clear? Participants?
Yes, sir. Yes.
There are two types of control, servo control and regulatory control. So regulatory control is very, very important. So this is one kind of a block diagram representation. So which consists of dynamics, kinematics, buoyancy and gravity, hydrodynamic coefficients, thrusters, deflection. These are mathematical equations. I'll skip it. So we have to cover. So mathematical modeling means this state space model. So 6 degrees of freedom model, and these are the outputs x, y, z, phi, theta, psi. These are the displacements u, v, w, p, q, r are the velocities. So these values, so all these second part is used for simulation. This is a w, what is the value of m, w, b. So because we don't have vehicle, so these are available for, if you type in the Google infant vehicle models, so you will get these values. So once you get these values using MATLAB, you can do some kind of simulations. So this is I have done my research in the area of this pyramidal underwater vehicle. So we have developed some convention. We applied some conventional controls to the advanced controls. Conventional controls are PD control, LQR. As you mentioned, this PID control means proportional integral derivative control. So what is the advantage of PID control? Can anyone participate in discussion?
It eliminates the steady state error, sir.
Anything else?
And response also is faster compared to PDPI, etc.
Okay.
Sir, you are asking the advantages of PID controller itself.
No, why PID is popular in nowadays? Also, people are using PID. See, artificial intelligence based PID.
Simple to understand and easy to tune.
Easy to understand, easy to tune. Okay.
Yes, sir. And easy to design also.
Any other inputs?
Sir, for control both the steady state and as well as a transient response, both can be done through this PID controller, and as well as by the Ziegler-Nicholas method, we can easily obtain the solution. Am I correct, sir?
How to choose these KP, KI, KD values? How to select KP, KI, KD values?
If we are using Ziegler-Nicholas, then we are going for ultimate time, ultimate period, and we are following the table for KP,
Okay.
KI, KD.
So one has to use Ziegler-Nichols tuning method. So see, in other way, this PID control, why it is popular means, P means proportional. We can say this proportional means output is proportional to input, which gives the present action. Okay. Integral control means past. Derivative control means
Future.
So it consists of present, past, future actions. So that is the reason this PID control is very, very popular. But if you look at the transfer function, it is not physically realizable because transfer function is Kp plus Ki upon S plus Kd into S. So numerator power is greater than denominator power, which is physically not realizable. So we have to use filter along with the PID control. Otherwise, in hardware, it will not work.
True.
That is the limitation of PID control. One has to use filter along with PID control. So why it is most popular means it gives present action, future action, and past action. That is the reason people use fuzzy based PID control, neural network based PID control, because the other controls will function based on logic, but this controller will function based on some mathematical formula. Similarly, this LQR means
Linear quadratic regulator.
Linear quadratic regulator. So here the concept is how to select the value of Q and R. Okay, so this selection of Q and R can be done with the help of so many methods. Again, you can use fuzzy. Again, you can use
Riccati equation.
Riccati equation. All these. The idea is how good you are selecting the values of Q matrix and R matrix. For a single input, single output system, what is the value of R? What is the value of Q? For multi input, multi output system, what is the value of R and what is the value of Q? So those things plays a key role. And next, as I mentioned you, the sliding mode control, model predictive control. So model predictive control, what is the beauty of model predictive control? Those who are working on model predictive control, can you please participate in discussion? Anybody is working on model predictive control? Why it is popular? Okay, I'll tell you. Are you with me?
Yes, sir.
Model predictive control basically it is also works like PID control. Like with the help of past and present information, we can predict the future. That is the reason it is called as predictive control. If you look at the mathematical equation, because time is not permitting me, otherwise I'll explain. This with the help of past and present information, we can predict the future. So that is the reason it is uh, one of the popular. Another thing is it is applicable for multi-input, multi-output system. Most important thing is constraints. Suppose if you are operating motor in different speeds, so those constraints can be considered in the case of model predictive control. So that these are the unique features of model predictive control. So this sliding mode control, how you are making that surface, how you are writing the mathematical equations for that. That is important. See, most of the model predictive control systems may not give stable response. So for that, first we have to check whether the system is stable or unstable. Sometimes the model predictive control may fail on unstable systems, may not give fruitful results for the unstable system. So we have to check whether the system is stable or not. This is a spiral underwater vehicle. I'll show you one video later on. These are some of the results. So this is our block diagram we developed for the spiral underwater vehicle. Reinforcement learning. Any of you are working on reinforcement learning? Okay. So these are taken from this www.mathworks.in. So here you see both the figures. These are synonyms to normal conventional control system and reinforcement learning system. So normal conventional control system, this is a plant. You may consider it as a robot. This is controller, reference, measurement, manipulated variable, error. This is everybody knows this mechanical engineers, electrical engineers, and reinforcement learning. So what is the synonym equivalent to this generalized control system to the reinforcement learning? So environment is considered as plant. So you see here adaptive mechanism, RL algorithm, cost function or error function, reward, manipulated variable, action, measurement, observation, plant, environment, controller, policy. So reinforcement learning has parallel to control system design only. So what you understand from here? So if you are good in control system part, you are directly or indirectly, you are also good in reinforcement learning programs. So the same thing, if see reinforcement learning workflow starts from like this: environment, reward. What is the reward? You can see the reward is cost function. Agent. What is the agent? Agent is controller. So this is tuning. Training is tuning. Testing. So we can better understand from this here. So this is plan. This is reward, agent, training. If everything is okay, if it is not success, then we have to go for the redesign, retuning likewise. So what can be done? Approach one is using a hierarchical approach. So these are conventional controls like PID, LQR, MPC, and this is planning, scheduling with reinforcement learning. So with the help of this reinforcement learning, we can tune these PID parameters, LQR. See what is happening here. It is a cascaded loop. So this is conventional loop. This is motor. So motor which controls position and speed. Perception here is this is normal control loop and this is reinforcement learning. How we have to schedule these PID, KP, KI, KD values or Q and R values or model predictive control parameters. Another approach is using verifiable or legacy controller as a backup. So you see the switch. So if it works with the basically with the normal conventional controls, no need to go for this reinforcement learning. So if it is, so you can do comparative work here by changing the switch. Now the another approach is using post-processing module. So this is one such approach, reinforcement learning agent, manipulated variables that is given to this post-processing module, then it will control the. So all these very good videos are available in mathworks.com. Whenever you have time, please watch this, you will get a good idea. So here, this is another approach is use reinforcement learning with traditional controls. So this traditional control is U, reinforcement learning is delta U. So now this is summing up here, U plus delta U, it will give better results. It may give better results. So this is analogous to control system. You see now, controller means policy, planned means environment, actuator commands means actions. So now what is happening here? This is input, this is output. So input, output are measuring. What is input? If you measure input and output, it is called as observability, or in terms we can also, in control system language, it is also called as system identification. So system identification, observability, Kalman filtering, all these things are inbuilt or directly or indirectly related to the reinforcement learning algorithm. So controller is policy, state feedback means observations. So this pink color and red color, these are synonyms to this reinforcement learning. This we had already discussed this features of PID control. As I told you, servo control means with respect to input, with respect to disturbance is called as regulatory control. So if you use both servo and regulatory control, it is called as 2 degrees of freedom PID control. There are two terms, proportional kick and derivative kick. So what happens if you choose the value of Kp is very high, and what happens if you choose the value of Kd as very high? What kind of results it will come? So anti-reset winding. So these are the terms. 1 degree of freedom is this one. 2 degrees of freedom controller is this one. 2 degrees of controller. So it consists of both servo and regulatory. So can you please tell me what is the nature of this response? What is the name of this response? Participants?
It is
Yeah.
natural response. No?
No, I told you the servo response and regulatory response. Na? Is it a servo response or regulatory response?
So there is no disturbance, I think. So that's why it's servo response.
No.
It is
See, observe here. This is 0 to 5, 0, and then it is increasing again, coming back to 0, right? So this is with respect to y of, look at the
Acha, disturbance is there. Okay. So like
y of s upon d of s. So this is with respect to disturbance. So
disturbance.
disturbance came, then it goes to 0, right?
Okay. Done.
So look at the last portion, closed loop transfer function of 1 degree of freedom controller structure, closed loop transfer function of 2 degrees of controller structure. So this is y upon ysp. So this is called as 1 degree of freedom control structure. 2 degrees of freedom control structure consists of 3.8 b into s. This b plays an important role in 2 degrees of freedom. We'll see how it will work. So this is called as servo response. Okay. So this is step input, and this is called as servo response. Now the role of 0. So if the location of 0, these are 0 locations. The zeros, blue color one, green color, red color, all these are 0 locations. So if the 0 location is there, then how the response is varying. So these are called as 2 degrees of freedom PID controller. With the help of this B, we can modify the result. Proportional kick and kick elimination. These are regulatory responses. This is anti-wind-up reset scheme. This is called as the digital controller. This is applied on the two-tank process. Gain scheduling PID control. Now we'll look at these land-based vehicles. My time is approaching. Land-based vehicles are, let us consider car as one example. So what do you mean by real-time? Look at these two figures and what is your observation? Participants, are you with me? Hello?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Look at both the figures and what do you mean by real-time control system?
In the above figure, the response is delayed, so already the accident has happened.
Okay. Right.
In the lower one, he has managed to apply the brakes in right time.
See, real time means at what time we applied the brake. That is important. If you apply the brake at right time, then there is no accident. So that is the second figure. If you apply, simply you apply the brake, but you did not consider the time, then there is an accident. So everybody will apply, right? All drivers will apply the brakes. But if you apply brake in the right time, then it won't give any accident. So these are the application fields for robotics. These are used in cement plants and most of the industry. Central figure is a robotics used in most of the cement plants now. Even this YS Rashek Reddy is having one, this Bharati Cements. The cement bag they used to write, robotic technology is used. So those are called as robots used in manufacturing industries. The top left hand side is it is used in biomedical engineering because this, what you call, even bypass surgeries nowadays. Bypass surgeries are also done by robots. And this top rightmost side is flight vehicle, aeroplane. Aeroplane is also having one kind of robot. Mobile phones, cars, all these are different application fields of robotics. Have you heard anybody is doing work on assistive robots? Assistive robots?
Yeah, it means robots meant to assist, especially old age people or people who are handicapped or something like that.
Are you working on assistive robots?
No,
Okay,
not
okay.
working.
So luckily in India, most of the people are taking care of our senior citizens, whereas in US, most of the senior citizens are taken care by this assistive robots. So a lot of research is going on towards assistive robots in foreign countries. So there is no maid in the homes. So only these assistive robots are doing the routine work for the senior citizens.
Yes, sir. Dishwasher. It can be even a dishwasher. Like
Yes.
a social robots means which just give company to the old age person.
Yes, yes. Daily routine works are done by this assistive robots. So, hope we should not use those assistive robots in India. But there is a lot of scope in the research. If you want to publish good papers, this one of the topic is assistive robots. So for our students, normally if we can able to interface Arduino with sensors and microcontroller or Arduino to sensor and motors, that is the basic thing to learn about to build any small kind of robotic work. These are, if you consider the land robot as a car, reaching the destination safely, that is very, very important because daily we are driving from our home to the college or a working place. So we know that route we are comfortable to drive in every day, but every day there is a challenge. Sometimes there is a traffic jam, sometimes sudden obstacle will come. So uh, these are all considered as always this trajectory tracking is always a challenging, even though it is. So active safety systems are anti-lock braking system, traction control, electronic stability program, electronic brake force distribution, adaptive cruise control. So if you take all these features in a car, your car cost is more than 20 lakhs. If you choose what are most important here, if you can you prioritize this?
ABS is the most important.
ABS.
Yes, sir.
Okay. What about ACC?
Yes, it is also the next one.
Okay. Track.
And usually these things are there. What we say, ECUs, electronic control units for engine management.
Mhm. Okay, so what I mean to say is if you increase the feature, the cost of the car will increase. Like in mobile also, if you go for more features, more and more features, then cost of the mobile also will increase. Traction control, what do you mean by traction control? Any idea?
Yeah, it may increase the power supplied when the vehicle is going uphill, something like that, sir.
No, very good, very good. When you are staying hilly area, we have to go for this option, traction control system. Do you know anybody is from any participant is from Karnool? Or you imagine you are driving from Tirupati to Tirumala. Okay, Tirupati to Tirumala. There is a challenging task, right? That road is zigzag road, right?
Yes, sir.
So there traction control is required. The
Yes.
hilly area, this traction control is very, very important.
Yeah.
Passive subsystems are airbags, seat belts. This is anti-lock braking system scheme. So if there is an anti-lock braking system, the car will take the diversion. If there is a no anti-lock braking system, it will hit the object. Components of anti-lock braking system. The block diagram of anti-lock braking system. Try to analyze this. This is wheel, calculating slip, AB as you said, ECU engine control unit. So this top one is controller. So if you analyze one quarter car model, then you can analyze easily for the entire model. This is called as quarter car model. Adaptive cruise control. So adaptive cruise control is uh, how Adaptive cruise control is ideal for stop and go traffic and rush hour while keeping your car at a safe distance from one in front. So it means if you are an experienced, so adaptive means the dictionary meaning of adaptive is to change based on the road conditions. This is the working principle of adaptive cruise control.
अरे खुश रहिए कैसे हैं
Sir, Rupak sir, please go on mute, sir.
Now we entered for the Hero robots. So this is missile control. So this is airframe. These are the effectors. These are the sensors. This green color one is a flight computer. This is guidance, navigation, control for the aero vehicles. These are different types of forces used in the flight control. From this diagram, you can understand there's a translational, there is a lateral and longitudinal control. So from this table, primary control forces are their stern plane, rudder. Here the terminology is aileron, elevator, rudder. Airplane movement is roll, pitch, yeah. Axis of rotation is longitudinal, lateral, vertical. Type of stability is lateral, longitudinal, directional. So this is again with respect to the control system diagram, aircraft conditions of motion. Inputs are aileron, elevator, rudder, throttle in the case of flight vehicles. Atmospheric disturbances, flight conditions. So flight condition also plays an important role. What is the aging of the vehicle? So those things we have to consider. So recently there was an accident in Ahmedabad, right? Flight accident. It was happened because of the because of what from this figure? Is it from atmospheric disturbances or flight condition? Participants?
Flight condition.
Flight condition. They have not. The pilot did not observe that one of the valve is closed. That fuel valve is closed, right? That is the reason the fuel is not. So pilots are saying we have not done it, but because of the aging of the system, that valve may automatically shifted. That may be the prediction because since it is in the court and people are doing this inquiry, the observation is even this Rashikar Reddy, this craft also gone for the accident because of the flight conditions. Atmospheric disturbance may be also. So the role of control system engineer is your vehicle should respond with respect to input only. Your vehicle responds with flight condition and atmospheric disturbances are as minimum as possible, if not zero. So this is again rigid body rotational dynamic. One example is taken.
Sir, pardon, sir. Please repeat that last statement. What is the role of the driver, flight driver, pilot?
What I mean to say is the output should not see control. The design of controller is he should design the control in such a way that it should respond with respect to input and it should minimize the effect by this flight condition and atmospheric disturbances as minimum as possible, or else if not at least zero.
Yes, sir. What I understand from the entire discussion till now, the input given should definitely able to take care the flight condition and the atmospheric disturbances.
Hey, input will not take care of the condition.
Is the control output should be
controller output should minimize the
effect of flight condition and the
flight condition and atmospheric disturbances. So this is called as regulatory control in terms of general control system engineering. So
sir.
This top one are called top and bottom are called as regulatory control.
Yes, sir.
So we have observed some responses also, right? If there is a disturbance like spike will come, it should come down to zero. Okay. So because of this atmospheric condition, the controller immediately should act and the response should goes to zero. Okay.
Sir, yes.
Clear?
Yes, sir.
So rigid body dynamics with respect to the flight vehicle. So these are the nomenclatures used in the flight vehicle. So this is actuator model. This is gain, vehicle dynamics, major subsystems of missile guidances. This I have taken from this PN Divedi. There is one guy, PN Divedi, who is working on this aerospace vehicles at DRDO ARB, Aeronautical Research Board. This is three loop guidance. See, the guidance is this is at ground, and this is the target. So, what is the name of this guidance? Can you guess?
It is a
Hmm?
pardon, sir. It is
What's
missile.
the name of the guidance technique? This is missile trajectory for missile vector velocity.
Projectile motion, projectile control.
No, this is called as dog cat chasing method. Dog cat chasing method.
Okay, okay.
So initial guidance, which we call in terms as line of sight guidance also. These are all lines, right? Line of sight.
Yeah, line of sight.
This is missile at ground. This is the enemy. So, yes.
Please complete.
Okay. Okay.
Complete in 10 minutes, sir.
Okay.
In case
Okay.
of
Okay. So
session
this is
time.
see, always dog will not go straight to catch the cat. Continuously it will bend till it catches the missile. So these are proportional navigation. Okay, I'll show you some video. Is it visible?
Yes, sir.
Yes, sir. Video visible and audible.
Yes, sir.
Is my video playing?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Now you see right hand side the MATLAB simulations, left hand side these are the animations of the flight. So how your parameters are controlling this pi, theta, c, Dutch roll. Okay, so these things you can do it in the MATLAB. So MATLAB you can imagine these things. You can visualize. You can analyze it easily. So this is for the. Let me come back. Is my screen visible now? PPT?
Yes, sir. PPT visible.
Okay. So thanks to all the organizers, particularly congratulations to organizers for getting the funding from the external source from the ministry, and thanks to all the audience for the patient listening. And I too learned something from the participants that linear control can apply for the nonlinear system in some cases. like HV control. So most of the work I have gained from this National Institute of Ocean Engineering, Oceanography, Goa, DRDO NRB lab, and DRDO this Dehradun. So there is one competition in the organized by NIO, National Institute of Oceanography. So you can make your own vehicle ready for to participate in the this competition that is called as SAVE, Student Autonomous Vehicle Competition. This organized every year, organized by this NIO, not NIO, NIOT Chennai, National Institute of Technology Chennai. So you can train your students towards this. So these are the organizations working on this marine robotics, IEEE Ocean Engineering. So as I told you, this is a non-profit entity. Non-profit entity means they won't take any registration charges if the student is a full-time student. It's Ocean Society of India, National Institute of Ocean Technology, ESSO. That's all. Over to the organizers. So that's all from my end.
Sir, if you can share your presentation, then it would be very goodful to us, sir.
Oh, sure. Sure, I'll send it to the organizers. Any queries?
Hello, sir.
Yes.
Yes, actually, this is Dr. Ravi Shankar, sir.
Yes.
I'm
Yes.
okay. Uh, Actually, my area is under control. Okay, so and my work is related to AUV only. Research. Okay,
Related
and
to?
nice to hear underwater autonomous underwater vehicles.
Okay. Okay.
Okay, and nice to hear you about your presentation from control perspective. Okay, and I have one question related to that hardware you designed in your labs. I think so. That spherical robot you designed, right?
Hmm.
Yes.
No,
Okay. So
whatever I have shown, that is
yes.
not my vehicle. That is vehicle we have taken it from the paper.
Okay.
So
No, the
we
last
have
demo.
our own models. We have our own models in the laboratory. Tell me, what is your doubt?
Okay. Doubt in the sense, can I get a guidance from the design perspective, or can
Yeah,
we
I have
use
dropped. I
your?
have dropped my email ID.
Okay.
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 So
Okay. Fine.
see, if you want to explore in this area, this IIT Madras, there is one separate department, ocean
Yes. Yes.
engineering.
Yes. Yes. Yes.
They
Yes.
used to organize conferences every alternate year. So if
Yes.
you participate in that conference, you will get lot of exposure that where your papers will publish easily, or what is the current research trends in the field of ocean engineering, autonomous underwater vehicles. See, most of my research followed by this Shantakumar, he's a
M.
professor in
Santa Kumar. Yes. Yes. Yes.
IIT
Right. Right.
Madras, and his guide Ashokan from IIT
Ashok.
Madras.
T. Ashok. Yes. Yes.
These
Yes.
two persons, if you read the papers of these two persons, you can gain lot of knowledge. I followed most of my work from them.
Yes. Yes, sir. Okay. During my PhD, I followed them only.
This Pramod also I have taken
Yeah.
some.
Pramod also. Yes. Yes.
Pramod, even Antino Pascal is my PhD examiner. Foreign examiner is Antino Pascal.
Yes. Yes.
And if thesis released from Antino Pascal, that is the biggest honor. You
Yes.
might be
Correct,
saying.
sir. Yes. 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 No, I met him personally, sir. I'm in touch with him on
No,
this
he evaluate each and every line.
line. Yes, sir.
It was a really very tough time for me to pass from the external examiner. Now I
Very
had
good,
very
sir.
good relation with Antino Pascal.
Hmm.
Shantakumar also you might have invited organizers. He's a very good.
Yeah. Yes, sir. Currently,
I
yes,
dropped
sir
my
is
email ID. I dropped my email ID. Please keep in touch with me. Okay.
okay.
In,
Okay, sir.
in the in the chat box, I have dropped my email ID. So please, okay,
Okay, I'll be in touch, sir.
keep in touch. Okay.
Dear participants, any doubts, please feel to ask. Otherwise, we'll wind up the session and next session resource person is waiting.
Okay, sir. We'll go with vote of thanks. Kondai, sir. Please carry on, sir.
Thank you, sir. Sir, it's a great honor to propose the vote of thanks for today's insightful session. On behalf of ATAL FDP organizing team, I extend my heartfelt gratitude to Dr. M. Panduranga Prasad Garu for delivering a deeply informative lecture on Introduction to Robot Control System. Sir, your discussions on guide and mentor and modeling of robotics, and hydrodynamic terms, and also with the real-time embedded control systems uh, and discussions on ABS are given more insightful information for the participants. And also your valuable talk on marine robotics, advanced control techniques, and underwater vehicle systems has greatly enriched our understanding, sir. We sincerely thank you for taking time to be with us, for sharing your knowledge, sir. And also, due to time constraint, uh, we are unable to discuss more topics, and it is very informative session, and it is enlightened our insights in the underwater vehicle systems. Thank you so much, sir. I would like to uh, also express my thanks to all participants for their active involvement, and, uh, and also for continuous support for making session successful. Once again, thank you, Dr. Panduranga Prasad Garu, for enlightening and engaging session. Thank you, sir.
Welcome, sir. Welcome. May I leave now?
Yes, sir.
Okay.
Yes, sir. Thank you very much, sir. Thank you.
Thank you, sir.
Thank you all.
After 5 minutes, we'll have another session. Thank you, sir.
Thank you, sir. Sir, Vikas, sir, are you available, sir?
Yes, sir, audible, sir.
Vikas, sir, Vikas. Next speaker, Vikas, sir.
Yes,
Yes, sir. Sir, hearty welcome to SV Colleges of Engineering virtually.
Yeah, thank you so much. Thank you so much.
Sir, we'll start the session by 2 minutes, sir. We'll have a small break.
Sure, sir, no problem. Sure, no problem. We'll start in 2 minutes.
Dear participants, actually we shared feedback link in Google Meet chat box, but it is accept the feedback after 8:30 p.m. only.
सर आपसे रिक्वेस्ट है कि अटेंडेंस का आप 8:30 पे प्रोवाइड कराया करें सर। बीच में अटेंडेंस
Both sessions we are taking at a single time, ना?
सर बार बार अटेंडेंस बोलते सर 8:30 पर ही आप अटेंडेंस प्रोवाइड कराएं।
8:30 link we will provide, sir.
Yes, sir.
Can you speak in English, sir? I can't able to understand your Hindi.
So please provide attendance form after 8:30.
Yes, sir. Yes, sir.
Yes.
We will once again post the feedback link after 8:30 in chat box.
Okay, sir.
Sir, Dr. Kondai, sir.
Venkata Kondai, sir.
Yes, sir. I think we can start, sir.
Okay.
Yes, sir.
So, good evening to one and all. Now, I would like to introduce our distinguished speaker for today's session, R. Vikas Reddy Garu, Managing Director of RoboMonk, UAE. Vikas Reddy Garu is the founder and CEO of RoboMonk Technologies Private Limited and has been serving as a Managing Director of Technothron since 2015. He also contributes academically as an industry representative on the Board of Studies at Annamacharya University, Rajampeta. His field of expertise spans across the robotics and embedded system designs and electronic circuit design and troubleshooting, PCB designs and implementation of protocols and microcontrollers, and also his achievements, uh, having impressive list of achievements. He has conducted over 100 workshops in engineering college across India and has trained more than 10,000 BTech students. And also he has established STEM robotics labs in 6 international schools, signed MOUs with over 15 engineering colleges, and actively participated in various national level robotic competitions. We are honored to have him with us today to deliver a session on basics of robotic programming, offline and online methods. Thank you, sir. We will welcome you, sir, to take over the session.
Sir, Vikas sir, shall I stop my presentation, sir?
Yes, sir. Thank you so much for the warm welcome. And could you please give me access to share?
Yeah, now I think you can share, sir. Sir, you please switch on your video, sir, so that we'll take the photograph.
Sure, sir.
For filing purpose. Sir, are you there, sir? Yes. It is visible, sir. Yes, your screen is visible.
Okay. Okay. Now I'm switching on my video. 1 second, sir. Yes, sir. Am I audible and?
Yeah. Both you are audible and visible. Yeah, correct. Thank you, sir. Thank you.
Thank you so much. So good evening, everyone. So myself, I'm Vikas Reddy. So thank you all for inviting me to this session. First of all, I would like to thank SVC and the ATAL program for inviting me here. So today we'll explore how robots are programmed in industry, and we'll see some demo using some real-time, simulation tools we have like Gazebo, and we have also concept of ROS, robotic operating system. So we'll explore more about it. So the today agenda is we'll see how the robotic programming architecture, okay, and what is the programming flow for both offline programming methods and as well as online programming methods. And also at the end of this session, I will also show you the simulation in Gazebo, how actually we can simulate any kind of models, robotic models, robotic arms, or any kind of robots in Gazebo. And the applications of these in Industry 4.0 as well. So if we talk about the robotic programming, so here it is the process of creating instructions that how a robot should move, behave and interact with the environment. Okay, simply we are telling robots how to move and what to do. Just like we write code for computers, we write instructions for robots as well. So it involves like, here you can specify how the robotic, the motion path should be, what should be the speed of the robot, and what task it has to perform. Okay, and you can also mention the decision-making logic. Okay, and there are many, the programming languages. If you want to write a program for a robot, we have a lot of programming languages like C, C++, we can use Python. Okay, so using these languages, we can give instructions to the robot. Okay, we can define the motion, we can define the speed. Okay, and we can define the functionality of the robot. What functionality it has to perform? Either it can be, it can be, detecting some object or identifying and recognition, or it can be a pick and place robot, or it can be, inspection robot. Okay, we can integrate sensors. Okay, and which can sense its surroundings, and it can, give a feedback to the controller so that it can take a decision. And we can also integrate artificial intelligence. Okay, so to make it, autonomous and a smart intelligent robot. So if you see the programming architecture, so this is a basic architecture. Okay, so here if you see, these are the components we have when you want to write a program for the robot. So first thing is we have robotic controller, and then human machine interface, and then we have programming language, and then we have motion control system, and we have sensors and actuators. So it processes. So if you see the first one, the robot controller. So it is a brain of the robot which processes all commands, and it controls the motion. If you see about the HMI, human machine interface, it is your interface for for running the programs. If you want to control the robot, if you want to interact with the robot, you need some HMI model. Either it can be a joystick or anything which you can control the robot. So interfacing, human machine interface. So how you are going to interact with the robot, that is HMI. Okay, and we are using programming languages as we discussed, which defines the robot behavior, while the motion controller ensures smooth and accurate movement. And we have sensors and actuators. So here, sensors which help the robot interact with the environment, and actuators which is actually giving the movement of the robot. So the actuators can be linear type of actuators, it can be rotational type. So we have linear type of actuators like pneumatics, hydraulics, and whereas rotational type actuators we have DC motors. So what kind of actuators you want to use, so that we can define, and what kind of sensors we can use, how the motion control system should be. So all these things we have to define before we program the robot. So this is the main architecture that we need to follow before we start the programming of the robot. So we need to identify which controller we have to use. Okay, and we need to identify which HMI device we are going to interface, and what is the kind of programming language. It can be C, C++, Python, or other scripting languages what we can use. And the motion control system, we can say the locomotion system, the ability to drive. So the locomotion system or motion control system we can define, either it should be there 2-wheel drive or 4-wheel drive or a 6-wheel drive, or it should be a robotic arm. So what is the kind of motion control system you want to give to the robot? So next, what kind of sensors? So based on the application, if you're going for any object detection or identification robot, so what kind of sensors we can use? There are lot of sensors to detect its surroundings in the environment. We have sensors like proximity sensors, motion detection sensors, sound detection sensors. We have cameras. We have lidar sensors, and for identification of objects we can use cameras. and for identifying the location, for identifying the coordinates, we have GPS. So like that, what are the kind of sensors the robot you have to define based on the application? Okay, and the safety systems. So what safety system you can use to make sure every operation what you're having in the robot is safe for humans and the robot as well. So that also you need to define. So this is the main architecture of the robot when you want to start with the coding of the robot programming. So as we have seen the architecture, so here the types of robots. If you see, there are types of robots, and what kind of robot you want to go for. Like it can be a mobile robot, autonomous guided vehicle. It can be a two-wheeled, four-wheeled autonomous guided vehicle, or it can be a robotic arm with degrees of freedom. It can be a 3 degrees of freedom, 4 degrees, 6 degrees, and it can be a bipedal walking robot. That can be, it is a humanoid robot. And then, okay, so what kind of robot you want to utilize for your application? So you have to define the mechanical structure of the robot. So we have humanoid robots, robotic arms, two-wheel, four-wheel autonomous robots. Okay, we have spider kind of mechanism like quad robots, quadruptors. Okay, a spider mechanism robots, dog mechanism robots. Like we have seen, the dog mechanism. Like if you see, Boston Dynamics have developed a robot dog. Okay, with a four wheels, with which looks like a dog mechanism. So what kind of robotic mechanical structure you want to use? So that you need to define. And what are the motion types? Okay, like how the joint motion should be, the linear motion, circular motion, how the motion must happen. So the joint motion moves each motor independently, whereas linear motion ensures the robot end effector travels in a straight path, which is critical if you see in welding or painting application. The linear motion. Okay. So the next one is circular motion. If you see, so it allows the robot to follow curved paths around a defined center point. If you talk about blended motion, the blended motion, if you see, you can see the transitions between points. The blended motion in the sense it smooths the transition between points, reducing vibration and improving cycle time. Okay, so that is these are the different motion types we have. And coordinate systems. So here robots are using coordinates to make some movements. Based on the coordinates provided to it, it will make the movement. Okay, for that there are different coordinate systems like the tools, base frame, tool center point. So these are the different coordinate systems used. In the robots. So there are, now the topic is about, the programming methods. We have two different methods. That is online programming and offline programming. So most people assumption is like, online programming in the sense that programming, writing the code online and, just checking in the simulation. But it is not. It is actually not. So online programming is the process of programming robot directly on the real physical robot. If you are directly programming the robot and uploading the code into the physical robot and you are testing it in real time, that is online programming. Okay, that means if you have a robotic system with you and you are programming it directly on the real physical robot, that is online programming. So there are different methods for online programming. Okay, so like teach pendant method, lead through teaching, programming on controller. So probably I have worked mostly on this online programming method for controllers. We have utilized controllers and microprocessors, where I have worked on various robotic projects. We have developed our own robotic model, starting from two-wheel model to robotic arm. We have developed different robotic models. Like we have developed recently a robot with the rocker bogie mechanism, six-wheel rocker bogie mechanism with soil investigation. Okay, so we are using here, the microprocessor. Like we are using Raspberry Pi for prototype development. So in the real time, we can go for NVIDIA Jetson micro process, which are GPU enabled. So based on the kind of processor or architecture, processor or controller, we have to use the programming method. Okay. So if you take one of the method, so these are the different online programming methods we have. So like teach pendant we have seen, right? So here we'll use like what is the home position. Like before we program, we have to identify what is the home position, waypoints, okay, the gripper control, and what is the speed and acceleration. So by utilizing, by identifying all these things, we write the online programming method. So here I'm going to show you a demo of how this programming is works in online method and offline method. So if you see online, you should have a physical robot as we discussed. So here in this session, as we have very less time, I'm going to show you a demo on offline programming method, that is OLP. Okay. So this offline programming method is nothing but programming the robots without using or touching the actual physical robot. That means you're going to simulate the robot. You're going to simulate in the virtual world, and you're going to test the robot in the simulation environment, how this is actually going to work in the real world, that you're going to simulate in the virtual world. So because, when you're developing a robot, if you want to go for a prototype, if it is, if it is having a complex application, it is going to be very expensive. It may cost you around 1 to 5 lakhs to develop the prototype. Depends on the type of the robot and the application. So here, if you follow this offline programming method without having an actual physical robot, you can program the robot and then test in the simulation environment. And there are tools where you can simulate and run the virtual robots. Like we have Gazebo, Robotics, MATLAB Robotics Toolbox, like that. So if you see, these are the OLP tools, offline programming tools, where we have Gazebo, Copaliasin, Robotics, and MATLAB Robotics Toolbox. And for industrial robots like ABB, KUKA, all these, they have their own studios, development tools. So here, if you see, we have worked on Gazebo, and today I'm going to show you a demo of Gazebo as well. So these are the most widely used offline programming tools. Okay, out of this, Gazebo is a excellent tool for physics-based simulation and ROS integration. So I hope you are familiar with the ROS concept. Okay, So that is a robot operating system concept. So ROS is not actually an operating system. It's a middleware software, middleware framework actually. So that we will also see. And if you see the Coppolia SIM, it is flexible for research and educational robotics. Okay. And this is for educational robotics. If you want to develop any educational prototype and if you want to test it, then Coppolia SIM is the tool which is flexible for educational robotics. And if you want to go for some industrial tools that you want to explore, you can go with the Robotic or ABB Robot Studio. Robotic is popular in industry because it supports many robotic brands, and mainly it is used for path programming. It is very easy to deploy in Robotic. So that is next one is MATLAB Robotics Toolbox, which is a great for the kinematics and algorithm development. If you want to use MATLAB Robotics, it is a great tool for kinematics and algorithm development, where you can check the forward kinematics and inverse kinematics in the MATLAB Robotics toolbox. Of course, you can also check in other tools. So, but this is best suitable for kinematics and algorithm development. And whereas this ABB Robot Studio exclusively, this is developed for ABB robots with high accuracy. So there are specific tools where their companies they have developed for to develop this offline programming for their particular robots, like ABB Coca. They have their own studio platforms to write the code. Yeah. So if you see the OLP workflow, we need to know there is a flow. Okay. First, we need to identify which robot model we are going to utilize. Utilize are we are going to define and we are going to utilize for our application. And then we have to define the workspace where we are going to test the robot, in what environment we are going to test the robots. Okay, so here first we start with importing the robot model, and then we'll define its workspace. Then we set the tool, and then we teach the required points and simulate the robot's motion to check for any errors. Okay, and we simulate the motion, and finally we export the robot program and load it into the real robot. So these are the workflow in offline programming method. So as I said, offline programming, we are actually testing in the simulation environment. So first we are importing the robot model, and then we are going to define the workspace, and we are going to set the tool, and then we are going to simulate the robot's motion to check if there is any error or any collisions that happens. And if it is working, then we export the robot program to the real robot. Okay. So these are the OLP workflow. And if you see the differences, the main between offline programming method and online programming method. So if you see in offline method, we don't need a robot to test the code or to upload the code, where we can simulate in the virtual world and we can test it. Whereas if you see the online programming method, to develop the code, and then once you write the code, you can test it in the real robot. So that is online method. So if you see, if you want to work with the real robot and in the real environment, you want to write the code and test it, there is a lot of safety concerns. There may be a chances of the damage of the components in the real time, and there is a very less safety for the robot, because there is a problem of errors or problems may occur for online method. That is when you're directly testing it. Before you test it in the real robot, if you go for offline method, the majority you will be having very less problems. So once you deploy your robot in the simulation environment, then you go for the physical environment. So it is going to give you a high accuracy, and also the time efficiency is high in offline method, because within the less time you can actually build a robot. First you can build a mechanical model in any CAD software. You can use first SolidWorks or AutoCAD, any other softwares, and you can use Blender to create a 3D model, and then you can import the 3D model and you can actually test it in the simulation tools like Gazebo. Okay, so the time efficiency is very high here, and the accuracy is also very high. So if you want to use for teaching model, like if you want to teach the robotics also, so best model is the OTP model, that is offline programming method. So if you want to do R&D and if you want to develop a real robot, then it is online programming method is better. Okay, and the most important thing when you are dealing with either offline or online programming method, the main important thing is the ROS. Okay, so this ROS, robot operating system, it is like a central nervous system in our human body. So if you see our human body, we have a central nervous system which connects all the body, your human, various parts of the robot, your human body, and to the brain. We have a central nervous system in the human body which connects all our parts, like our brain, our various, the parts of our human body, and which communicates the information from brain to other parts like your hands, your legs, your nose, your all sensory points. So when your sensory organs, when it is sensing something and is actually giving immediate information to your brain. Okay, so these are how it is happening. There is a central CNS, central nervous system in our human body. So the CNS is actually a communication channel between all your sensory organs and your brain and other parts of your human body. In the same way, the ROS also, the robot operating system, it is actually a kind of CNS, how actually it is there in the human body. It is the same system what we have in the robot, which connects all the peripherals in the robotic system, like the brain of the robot, to the sensors of the robot, and all the parts of the robot. It acts like a CNS, central nervous system. Okay, so ROS is not a software. It is not, if you see the word robot operating system, okay, it is not the operating system actually. It is a framework, we can say. We can say it is a framework which is used, to communicate the information from all the nodes. We say nodes. Nodes are the different, node is a point, which performs a specific functionality. Okay, so it connects all the nodes and gives the information and communicates between one node to another node. Okay, so what is node actually? It is a small program which performs any individual task. Like we can say one node is, which can read the sensor reading. Okay, and another node, we can have a motion control. Another node, we can have it for mapping. So node is a small program which performs any individual task. So like that, we can have multiple nodes. If you take a normal robot, okay, without any ROS, it is very complex to operate. Let's say we have a example. We'll take an example. We'll take an example that is a soil investigation robot for agriculture application. Okay, or else a soil investigation robot for space application. If you take a soil investigation robot, the soil investigation robot includes, the many functionalities. First thing, it should able to, move in a any particular environment. First, it is having movement, and it is having, camera for surveillance, like it is able to show the real world environment. Okay, camera is there, movement is there, and motion planner is there, and it can sense the, soil, the soil sensor. It can have soil sensor, that is, let's say NPK sensor. Let me explain with the notepad. So I'm going to share this notepad. Okay, I'm just sharing the notepad here. I'm just going to write. If you see the soil investigation robot, which can investigate the soil and which can tell you, which can give you the physical properties and chemical properties of the soil. Okay, this is one application I'm just taking as an example. Okay, so here, what are the different functionalities it has? First thing is it should have a basic moment. Okay. Next, sensing. It must be able to sense. Okay, it must be able to sense if any obstacle, because when it is moving, if at all is there any obstacle, it must be able to sense. And also the sensors, we can have obstacle sensors, and then we can have soil sensor, which can detect the soil physical parameters and chemical parameters. That is, soil sensor can be, example NPK sensor. So this soil sensor, like, which can detect the soil parameters like nitrogen, potassium, phosphorus, and also there are sensors like 7-in-1 soil sensors and NPK soil sensor. So this NPK only detects the soil parameters like nitrogen, potassium, phosphorus, and if it is 7-in-1 sensor, it can also detect the pH level, alkalinity, electrical conductivity of the soil. So this is one. And then we can have, let's say, we can also integrate a camera, and then we can also the dipping mechanism to dip the sensor into the soil. Okay, and you can make it manual and autonomous. Let's say you want to control the robot manually. That means controlling method. The controlling method can be manual or autonomous. Okay. So let's say these are the different functionalities. So what if you're developing the robot without ROS? And what is the difference it makes with ROS? See, without ROS also you can do, but the complexity is much, and in the real environment you'll face a lot of problems. Here you have a different functionality. First thing is one movement functionality is there, and another thing is it has to sense obstacle sensing and the soil investigation using NPK sensor, and it has to monitor, means it has to give the, it has to take the, it has to show the real world environment, and it has to send that feed to the controller, and then it should have a dipping mechanism which has a stepper motor, So we have stepper motor here. With the dipping mechanism, that is a screwing mechanism also we can say, which can, dip the this NPK sensor into the soil. Okay. And then if you want to make it autonomous, then it is fine. If you want to control this robot manually, let's say you want to show the movement, you want the robot to move left, right, forward, backward. Okay, then you will have also a manual controller, that is, let's say you are using a joystick controller. So you have multiple functionalities here. When you write a normal programming method without ROS, it is very difficult to communicate between all these functionalities, because when, let's say, when it is moving, when it is actually moving, okay, and suddenly there is an obstacle coming, okay, then it has to stop and then it has to take left or right. Okay, and then you find a point where you want to test the soil. Okay, so then you can also use this dipping mechanism using the stepper motor, where it dips this NPK sensor into the soil, so that it takes the measurements of the soil physical parameters, the physical parameters and chemical parameters. And then this sensor has to give the data to the, let's say you want to send this data to any cloud. Then again, you need to interface the IoT. To send this data to the cloud. Whatever the data it is detecting from the soil, all these physical parameters and chemical parameters, it has to send to the cloud. So we need IoT connectivity here. So here we are having almost, more than 6 different functionalities, where it is having a lot of complexity, and there should be a sync between all these functionalities. So if there is no sync, there may be a lot of real world challenges you may face when it is having actually deployed in the real world environment. If you use a ROS, robot operating system, okay, here you'll have different nodes where you can create node 1. It can be a movement or a motion planner. The node 2. The node 2, it can be, I hope this is visible, right? The notepad. Yes.
Yes, sir. Yes, sir.
Yeah. So if the node 2 can be, sensing the obstacle. The node 3 can be NPK sensor, like dipping mechanism with NPK sensor, where it can give the NPK values. The node 4 can be the camera functionality, taking the live video and sending to the any dashboard or web application, the live feed, the data. The node 5 if you are adding any other functionality. Okay, if you want to any. So here, if you use a ROS framework, this ROS framework enables all these nodes, okay, to communicate, to send this data to the controller. So here, the controller also can be a node. So the node can be here a sensor, a camera, a stepper motor, or a joystick controller which is sending the data wirelessly. So here, sensors, you see, sensors, all the sensors are receiving the data and it is actually sending to the controller. Okay, the sensor node it is sending the data to the controller node. And then the controller node is actually instructing the actuators to make the movement based on the actuators movement. Okay, so whenever this sensor, this obstacle sensor is receiving, let's say whenever the obstacle sensor is detecting an obstacle, it sends a data immediately to the controller, and then this controller will send the signal to the actuators to take the defined movement. Let's say the object is detected on the left side, then it, the controller actually tells the actuators to take the right direction. If there are obstacles on the both sides, then it takes the controller tells the actuators to take backward and take left. So it is actually giving the direction. Okay, and also if NPK sensor, whatever the data it is giving, the data first it is sent to the controller, and then the controller actually the sending, while if it is having internet connection, it is sending wirelessly to the cloud platform. So here the different functionalities all must happen with a proper sync. So for that you need a framework called ROS. So this is the example I have taken to explain about the ROS functionality. So this is the ROS. If you see the ROS architecture, one second. So if you see here the ROS architecture, so there are different layers here. First, the user code, where it is in the application layer. Okay. So if you come from the bottom, first there is an operating system layer. Okay, if you want to develop this, ROS framework, you have to develop, you can choose any operating system like Linux, where you can develop, Python or C++. So next, on the top of the operating system layer, like let's say in Linux, there is a concept called DDS. So what is this DDS? So if you see, so if you see this DDS is the data distribution service layer, where it actually distributes the data between the multiple nodes. And here if you see the abstract DDS layer, and then you have a ROS to client layer, this where actually, you deploy the client library. Okay, and then on top of that you have application layer. So this is the main architecture of the robot, where it involves, the nodes, and there are many tools in the ROS framework. We have tools like, nodes, topics, messages, services, action services. Okay, so these are all you can find out, in the ROS. There is a website with ros.org. So let me just open it. I'm just opening it. One second, I'm sharing the screen. Oh, sorry, I think, okay, I need to share the screen. 1 second, sorry. I'm sharing the entire screen so that, everybody can see. So I was explaining about, 1 second. 1 second. There is a problem. Yeah. Yeah. So are you able to see this roh.org?
Yes, yes, sir. Visible. Yes.
Yeah. So here you can identify, you can also see about the ROS framework. Here, this is the RS, this is ROS developer community where all the documentation is available. You can explore these. What are the different CLI tools and the libraries available? What are the how ROS frameworks? What is the architecture? You can see. So here is the latest tool, that is Jazzy in ROS. Here you can see all the tutorials. Okay. All the tutorials where you can see the CLI tools. Okay. All the command line in tools where you can actually explore about, configuring the environment. All this you can implement in the Linux, using Python code. How you can implement this ROS in Linux. Okay. So here you need to study about this. So this is a very huge topic actually, where almost you need to spend a minimum 2 to 3 months time to learn about this robotics with ROS concept. So this is a huge concept where you need to explore topics and tools like nodes, topics. Okay, you can see here. You need to, if you want to understand how this node works and how this topic works. If you see, this is a topic and this is one node and another node. So I hope you all are familiar with this publish and subscribe methodology, where we can select one topic and from one particular node to another particular node we can publish and subscribe. So let's say the publisher can be a sensor and the subscriber can be a controller. So publish nothing but sending the data, subscriber which is receiving the data. So here all the devices, so mostly in our robots, what are the different publishers and subscribers? So publishers can be, whatever the devices which are sending the data to the controller, and whatever receiving the data, that is subscriber. So here sensor can be a publisher and controller can be a subscriber. Subscriber receives the data through a topic. So this, you can select a topic and you can send the message like this. So it can be from one node to another node. Okay. And it can be one node to multiple nodes. Okay. If you want to perform a task using this task tool, so you can use these commands. It's clearly given. Okay. In the Python programming language. So complete architecture is given. You can explore more. And then topics, we have, you need to explore all these CLS tools. Services, we have parameters, actions. Okay, so you can explore through this particular ros.org website. And now let me tell about this. Yeah. So I'm going to share Yeah, I'm just showing it. Yeah. So now the PPT is visible, right? Like, okay. So now, yeah. So here, this ROS architecture, are you able to see the ROS architecture? What I have discussed?
Yes, sir.
Yes, sir. Yes.
Yes. So here, so this is the open source framework that provides, many tools, libraries, and communication layers where you can build, control, and coordinate actually the robotic systems. As I told, there are layers here. If you see the operating system layer, the first one is OS layer, where that is you can choose Linux or Windows. So most preferable OS is Linux, which is open source, and most safest environment where you can deploy all these ROS algorithms and test. And on the top of that, we have data distribution service layer, that is DDS, and then on top of that we have abstract DDS layer. Okay, and where this is the middleware. Okay, nothing but ROS. This ROS is a middleware interface where it can connect all the communication nodes, and it can act as a communication channel between all the nodes. Okay, next, if you see, this is the gazebo environment. I will show you, okay, how robots can be programmed inside the gazebo simulation environment. Okay, and how we can use this ROS framework. Okay, yeah, 1 second. Let me just on it. So actually, it is very difficult to show this, by running, Linux here in the laptop, because, the Linux is most suitable for desktop systems. Now I am into laptop. So I have recorded the simulation part. I'll show you that. Okay, 1 second. One second. I'm just opening the simulation. 1 second. Just. So are you able to see the simulation here? Yes. Are you able to see the simulation screen?
Yes, sir. Yes, sir. Yes.
Yes. So if you see, this is the gazebo simulation environment. You can see here. I'm just taking one example of this pick and place robotic arm. Okay, with almost 6 degrees of freedom. Okay, and which can actually, select these bolts which are present in this on the table. This actually identify the bolt. Whichever the bolt we want it to select, then it has to select that bolt and it has to pick that, and then it has to move in a different direction and then place it. So we will give the input to the robot to select the bolt. Which bolt it has to select. We will select it by the moves. Then it has to select that bolt. Then it has to move it. So if you see here, it can select the bolt actually. It is able to lift it. Okay. So here it has a camera also. So this camera is able to identify the bolts. Okay, there is an algorithm used here. There is an algorithm called YOLO algorithm, which is a computer vision algorithm, which has machine learning in it, which can identify, which is for identification, bolt identification and location identification. Okay, so here, first thing, to pick the bolt, first you need to calculate the position of a bolt, because it has to identify the coordinates of the bolt. Okay, so it has a camera. As I said, it has a camera. The robot has a camera. So robot, first it gets the feed from the camera. So the camera coordinates is different. The table coordinates is different. And how the robot sees the bolt is different. So there must be a match between all these, the coordination. For that, we are using a perspective projection transformation. There is an algorithm. We can use this transformation technique in the program to calculate the exact coordinates of the detected bolt. This, calculated coordinates, we need to define in the program. This transformation, we have to add in the program to identify the exact coordinates. Whatever the camera is seeing, the robot also must able to see, right? So that coordinates, identification of these coordinates, actually we can do with the transformation. Okay, if you see the program flow, here first the object detection, the bolts are detected using YOLO V8 algorithm. It's a computer vision algorithm where it uses machine learning. So here the boss coordinates of the bolts in the image are published using this YOLO. Okay, the camera is publishing the coordinates of the bolts using this YOLO algorithm to the controller. Okay, it is actually giving the coordinates of the bolt, where it is, to the controller. Okay, and the next program is there where it calculates the position of the bolt. That means this is a separate program which subscribes to this YOLO algorithm, and it displays the image obtained from the camera, and so that we can select which bolt it has to pick up. This bolt position program where we actually get the data to, we actually identify the bolt and select it. See here, this is the Linux environment where this is a Python program. Okay, this is bolt underscore sector.py. This is the Python code. Okay, where here this code, in this code, we are actually utilizing this camera sensor, which actually giving the image and video to the controller, and is actually giving the coordinates to the controller. Okay, using this, if you see the publisher and subscriber, here camera is a publisher. Okay, and controller is a subscriber, if you see. So this is the code developed in Python programming language. Okay, so like this, you have to develop a different codes for different functionality, and you have to create a project directory, and then you have to deploy. So if you see here, this is what we have seen. The code is the bolt sector.py is the code where the bolt image, whatever is present in the table, that is actually it is sending the data to the controller. So that is the program from the camera using YOLO algorithm we are sending. And then next is the controller program. If you see here, ARM controller program. This is the ARM controller program. Okay. So here, if you see, this ARM is getting the instructions from the camera about the coordinates, where actually it is the bolts on the table, And using this as I told transformation technique, we are actually, this robot is actually identifying the exact coordinates of the table, table coordinates where the bolts are present. So this is the code, if you see. Okay. So, and also this is the function for a gripper action. If you see, this is a gripper action function. How it has to hold, where it has to, the movement of the gripper, whether it has to open or close, for holding the bolt. This is a function what has been written separately. If you see the nodes, you can see the controller node here. I said, controller acts as a node, camera acts as a node, here the controller node. So we are creating different nodes in the program here using ROS framework. So in this program, if you see, different nodes are created. Okay. And the gripper action, this is one function for the gripper action. Okay, and this is the listener callback function where it executes all the commands that it is getting from the controller. Okay, so these are the different files, okay, that we need to create to execute this functionalities of the robotic arm. So if you see, we have to import the required libraries, and we have to install the, we have to create the ROS package. And then, we are using here, if you see, physics engine simulator. Okay, where this actually enables the Gazebo physics engine simulator. So here also, if you run this code, okay, the Gazebo simulator and this RViz visualization, you will get. So we have to install, to run all these programs and codes, you have to install all the commands, the ROS commands, the ROS package you have to install, the Gazebo you have to install in the Linux. Okay. And then you have to import all the libraries and tools required. And then you have to write the functionalities of the different nodes. And then you have to execute the bundle. So there is a flow that you need to follow that I'll tell you once after this simulation demo. I'll tell you the flow, how actually it happens for the offline programming method. If you see here, yeah, there are different files. Okay. These are the different joints, 3D model files, links. These are called. These are all should be used to to invoke into the Gazebo. So this is called robot description file. I'll tell you what are the different files you need to create to simulate in Gazebo. If you see here, these are the important files. I'll show you what are the files. Yeah, exactly. If you see, these are the different files. One is that moment file. Sorry, bolt sector.py. Then controller file, and then we have different source code files here. And there is one important file that is robot underscore description. If you remember, I will explain this robot description folder, what actually it contains. So there is a concept of URDF, the unique robot description format. That is the important thing if you want to start any simulation in the Gazebo or any other tool. So main thing is robot description. This robot description includes this, actually what are the different designs of the robot, what are the design links, joints, and what are the inertials like the weight, mass, force, okay, and also with how much velocity the robot has to move. All this robot description is present in this robot description folder. Yeah. So that is called URDF. If you see this URDF file, This actually contains the information of, as I told, the design. Okay, so this is on a GitHub. This is a sample code. This is a sample code. If you see from the GitHub, you can run this code. Where it is also publicly available in the GitHub. You can run this code, that is Roboticon, and you can test how actually it works in the gazebo. So once you give these commands, if you see these commands, you have to run the bash file first. When you are actually running this, gazebo or this RVs file simulation, you have to give this command. Okay, you have to set up this bash file, and then you have to launch this ROS. So all these commands you have to execute here to run this gazebo, and you have to actually see the simulation part. Yeah, if you see, after you launch the file, now this is what actually happened in gazebo. Okay, and this is the controller part where you will select which bolt it has to pick and which and it has to place. This is the controller, and this is where in a gazebo simulation how it actually happens. Okay, so we can actually see the movement. Okay, how in which axis is actually it is moving, whether the movement is accurate or not. Okay, and if any errors in the program, you can all test in this gazebo. Okay, so this is how this gazebo works, and if you see, this is the RVs, robot visualization. So the important thing for this offline programming method, okay, and to run in the simulation, the important thing is one second. Yeah. Yes. So the important thing is for if you want to develop a flow, if you want to develop a model, the first step is when you are designing, CAD model in the let's say SolidWorks or AutoCAD, any CAD software or Blender, you can use 3D model where you can create the 3D model. Okay, and then you can import the 3D model. So when you are developing this 3D model in the CAD software, there is an option called URDF generation. URDF. What is URDF? That is robot description format, unique robot description format. That URDF file includes all the data of this particular robot, the mechanical structure, how many links it has, how many design files it has, how many parts it has, what is the shape of the file, okay, how many joints are there, what is the inertial, what is the mass, what is the weight of each particular link or joint on the part of the robot. Everything is present in this URDF. So URDF file is very important to execute in gazebo, because once you get the URDF file, then it is easy to execute in the gazebo. So first one is URDF, then next one is controller. The controller can be motion planner or drive planner. Motion planner, which decides the movement of the robot. No, it actually decides how it actually move. If it is a robotic arm, it has 4 degrees of freedom or 6 degrees of freedom. How it is actually making the movement, that is decided by the motion planner. Okay, and the drive controller, which actually drives the controller. So that is the next thing. And then is computer vision. If it has camera, if it has camera, then it has to execute the computer vision model for object identification and recognition. Okay, and if at all in a camera, it can also identify if any collision detection is happening. Okay. And then the next thing is launching the project, that is launching ROS2. You can integrate this ROS2 and then you can simulate in the gazebo. So this is the complete flow of how this offline programming method works. Okay, so all these you need to program in the Python language. You can use initially the Linux environment where you need to set up first, you need to install a virtual machine. You can take, Oracle virtual machine box. Let me tell you the final conclusion. 1 second. In the notepad, I'll tell you the summary points. Let me share the notepad. Okay, I'm just concluding. So here I'm taking a new tab. So here, to use this offline programming method, so first thing is you need to have a 3D model. Okay, first you need to have a 3D model that with URDF file. Okay, with the unique robot description format. Then you will import that URDF file into your program, and then you have to create this raster framework. You have to add this raster framework. You have to install this raster framework, and then you have to execute. So next here, after URDF, you can have the controllers. The controllers, which can be motion planner example, and then a drive controller, and then one is robot description controllers, and then if you have a computer vision, you can use for object identification and recognition, and then you can launch. You can create a launch file. This all you can do in the Linux environment using Python. Python or C++, both you can use. Python is the most used language for this ROS2 framework. So you need to have a URDF file, and then you need to install ROS package in your Linux environment. And then you have to use controllers like motion planners and drive controllers. And if you have computer vision, you can use for object identification. So all these things, you have to create a bundle, and you have to create a launch file where you can execute. So once you execute the launch file, it will open the gazebo and RVIS, robot visualization tool. RVIS is a robot visualization tool. Okay, so you have to for this you have to install, before you have to install Oracle virtual machine, where you can install the Linux OS Ubuntu, and then you can install here. You can install Linux Ubuntu. In Linux Ubuntu, you can install Gazebo and ROS2 package. and you can use Python commands and code, Python language to write the programming, and you can create different nodes. Create nodes using ROS2 framework. Okay, and here these are the different controllers like motion planner, drive controller. Okay, and for computer vision you can use algorithms like YOLO, Gate, and motion planner we have like move it, motion planner. Okay, and launch file is the file which integrates all these things, everything, and which will create this simulation environment. It can launch your simulation environment, Gazebo or Wish, where you can actually see how the robot is actually working. So that's all about the programming flow of offline programming using ROS2 framework and Gazebo simulation environment. And I'm going to conclude in 2 minutes. 1 second. So you can so all the faculties can explore about this robotic arm simulation. We can take some applications like autonomous navigation robots, okay, object detection robots, ROS based using SLAM algorithm, pick and place robots. These are the different project ideas one can explore and interact with the students and develop some student based project using this Gazebo simulation environment and ROS2 framework. Okay, so that's all for today, and thank you so much. If you have any doubts, you can interact with me. Since this is a 1.5 hour is very less time to explain about this complex topic, ROS and Gazebo. I have just shown the demo of this. Hope you got some basic idea about the Gazebo and ROS, and you can explore and anybody, if you have any queries, you can ask.
Dear participants, if you have any queries, please. Now the meet is open for any queries.
Sir, what is the difficulty if it is tried in a Windows operating system? Yeah, Gazebo and ROS.
Sir, Linux is more flexible for Gazebo and ROS because that is where you can, develop, because all your Python code can be executed and these ROS commands also. You can also do it in Windows, but Linux is more flexible compared to Windows.
Okay.
Because without any error, so you can execute in Linux actually.
Yes, sir. Yes. Sir.
Yes. So
Okay.
yes. Linux is more flexible.
Okay, sir.
Yeah.
Sabita madam, you have raised your hand.
Yes, sir. Good evening, sir.
Yeah, good evening.
Sir, can you suggest some books from where we can, have these details? Because this presentation and materials are, I think, it's not enough to understand the entire logic and the details.
Yes, madam. Like you can explore. See, Gazebo also. There are website, the Gazebo simulation environment. You can search. I can show you. If you want, I can show you. Like 1 second. Something else. 1 second. So now I am sharing this this one. So you can see the Gazebo sim.org. Here you can explore, more about the Gazebo simulation software, how it works. It's completely open source. Libraries are there, simulation. It's a completely open source platform. Okay, how we can integrate all the peripherals, sensors. Somebody voice is coming between. Yeah. So this is Gazebo, ma'am, like gazebosim.org website where you can explore more about Gazebo and ROS. You see ROS, www.ros.org, robot operating system. This is also completely a open source. You can see robot operating system where you can explore all the details, how to get started, the installation. There are different versions. Okay, ROS to Zazie, ROS to Humble. Now the latest version is Humble, ROS to Humble. Okay, so how to install these? Everything is provided here. You see on the left side documents. Okay, for if you install Linux Ubuntu, for Linux Ubuntu, how to install this ROS2, everything commands here. You just need to copy paste these commands, and then you need to execute in the Linux command prompt, open terminal. So everything is clearly given. You can explore by yourself. Yes, any other doubt? Gazebo and ROS. I have told you, like any other queries.
Hello. Yes, good evening, sir.
Yeah, good evening.
Sir, can you just suggest any of the website just to refer like robotics and IoT if we want to teach to student the any platform? Like I mostly use the Arduino IDE for the text-based coding to teach.
Okay.
So like from scratch to IoT, if we want to explore more, then is there any website where we can get all the content from basic connection to the coding and running the projects?
Actually, it is a very big subject, ma'am, because everything is not available in a one single website. I can say there is a complete, there are a lot of topics. Even robotics now recently introduced as a separate branch, just like ECEEE,
Yes.
EAE.
Yes,
Yeah.
I know that robotics is now it is like in the curriculum of MCA or engineering also it is involved, but that student doesn't want to go in depth for the hardware component. They just want to know the programming and projects they can deal with. But
Yeah,
if
that's
you
what.
want to
Yeah.
I know that
Yes, yes.
that's it because they are the software student. Okay, so if we want to reach like and or explore even myself in more in depth in IoT, so any website or reference material which I can refer and projects. because every time seeing the videos and everything stuff is not possible.
Yes, 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 yes. I understand. But in this field, there are very less. Even if I see any robotics and IoT free learning platforms, I'm not able to get many much platforms where it is providing. So,
Because every
so
time
actually,
seeing the
ma'am,
videos and
from
everything
RoboMonk,
stuff is not
we are actually
possible.
creating a free learning platform.
Yes,
It is
yes,
going to be
yes, yes, I
launched in the next
understand.
6 to
But in this
10
field, there are
months,
very less.
where we want to provide,
If I
free
see any
learning
robotics and
tutorials
IoT
in the
free
field
learning
of robotics,
platforms,
embedded electronics,
I'm not able
IoT,
to
all
get
these
many much
concepts
platforms
starting
where
from,
it is providing. So,
Arduino basics to
because every time
advanced level Python
I
coding.
okay,
Yes.
Currently,
But
there
there,
is no platform
there is
available.
no, there are very less pre-plan. If you explore, I think we can find it out. I am not able to find out because there are only courses, companies, institutes where they are offering the courses, but there are
Okay,
very
actually,
less.
the multiple courses, but I doesn't get the time that I can
Yes,
see the video and explore it
I
more.
can say, ma'am, I can say ChatGPT is the best tool, or AI. We have a lot of
Chat,
AI tools. Yes,
yes,
I can
we have
say.
lots of creative, but every time it doesn't give the correct information.
No, no. For that, you need to understand the prompt engineering, ma'am. If you understand giving the right prompt, let's say, let me show. If you have time, like I can show how you can
Yes,
give
yes,
the.
I have the time, sir.
One second. Yeah, 1 second. So I'm just taking the example of ChatGPT, but not no. There are many other tools too. Like, what is your query, ma'am? Like, you want to explore?
In the field, more in IoT.
Okay, you want IoT. You want to learn.
I want to make a basic project on IoT like Wi-Fi control robot.
Okay.
So your screen is not
My screen
visible.
is not visible.
3 ROS service type, that only I can see.
Yeah. Oh, 1 second, 1 second, 1 second. Sorry.
Yes, sir.
Share my screen. Yes, yes.
Now it is visible.
So yeah, now it is visible, right? So I want to build a Wi-Fi.
Control robot.
So this is a specific project that you're talking about, ma'am. Like, okay, fine. I want to build a Wi-Fi controlled robot.
Yes.
So you can give a prompt that is, I'm a beginner with no idea of robotics, IoT. Please provide me best free learning platforms where I can explore robotics and IoT, and where I can explore robotics and IoT. These two, right?
Yes.
Yes, yes. Let's see what it is going to give. So if you have yeah, if you see Raspberry Pi Foundation, there is a Raspberry Pi Foundation website also. It is also open source, man.
Okay.
raspberrypi.org. You have idea, ma'am, like
Sir, currently I'm just using Arduino.
Arduino. Yeah, the next level is Raspberry Pi. Yes.
Because I'm just teaching from class 6 to master student.
Yes. So if you see here, ma'am, it is also giving you how to structure your learning as a beginner. First thing is, when you want to learn something, you need to first identify what I have to learn, because when you open in Google or YouTube, you'll get a lot of videos. Then you'll be confused which one to watch or which one to understand. The main thing is the structure of your learning path. Okay, from where you need to start. If you don't know anything about the beginner basic level of robotics and IoT, first you can get the structure of your learning path like this. What you can start. First, you need to understand the basics of electronics and programming, and then you have to understand the basic robotic concepts, and then you have to go for IoT Wi-Fi connections and robotics with IoT. So this is the learning path. Then based on this, you can give one by one this command itself here. So instead of, it will also give you different platforms where you can actually explore more about this particular single topic. And here, if you see, it has given all the Raspberry Pi.org. If you see, I think this is the best platform I can say, where you can learn all the coding, robotics, and Python. And to learn Arduino also is having complete tutorials, right? Here, Arduino.cc. If you want to learn about Arduino, here Arduino programming completely Arduino.cc is there. If you want to learn about something advanced, here if you see electronics and robotics, Raspberry Pi.org. Okay, teaching physical computing with Raspberry Pi Python, and then we have getting started. Yeah. So I think this edx.org is providing free courses, ma'am, actually. Free courses where there are many, tutorials, it seems. And yeah, one second, let us go back to this. Yeah. If you once you have given the prompt, it is giving a lot of platforms, ma'am. You see Raspberry Pi Foundation, EDX, IoT for all. And you can see here in ChatGPT itself, you can find out what are the free learning platforms. Sure. And then you have to understand your learning path week-wise. And then one by one, you can give the same prompt in the ChatGPT. So if you don't understand what actually ChatGPT is giving, it will also give you the different links to explore, different websites to explore. So like that, you can get the data. I don't think we can get all the data in one single website. That is I can say that's complex thing. But all the data we can get in ChatGPT. That is there.
Okay.
Yes. So you can see here. If you want to, I have given
Yes, sir.
one subject. Learn simple programming. It has given learn simple programming Python or Arduino C. Okay. Then it has given. If you want to learn Python, then free code camp. So because robotics is something multidisciplinary field where it involves electronics, computer science, the power supply, electrical, mechanical structure. It's a very multidisciplinary field. Robotics is. So you need to explore one by one step now. You can use this different tools. So let's say it is giving Python. For Python, it is giving different platform, free code camp, code academy, Google's Python class. For Python, I'm talking about. So once you explore about Python, then you want to learn about IoT. IoT free learning platform. If you see here, if you want to learn about Cisco Network Academy is there, where it is giving world-class beginner courses, totally free. And it teaches IoT basic sensors. Okay?
Okay, sir. Okay.
Yes. So like this, you can explore. There are multiple platforms. I cannot say, in a single platform is there. And if you want to explore simulation, you can see here. If you have idea about OP, you can simulate this Arduino platform.
Is there for stimulation?
Yes. So like this, you can explore now. If you give the right prompt,
we can get directly simulated robo through ChatGPT. Is that possible?
You mean 3D model, sir?
3D model, yes, sir.
Yes, sir, it is possible. If you give the right prompt, like let's say I want, the mechanical structure, like let's say 4-wheel model with 4 wheels. And if you give the measurements also, the box shape should be like this. Let's say you want in rectangular shape with 4 wheels. On the top of the 4-wheel, if you want robotic arm, then it will definitely generate. Yes. But I think you need to, for that, you need to have, pro version, it seems. A go version, like so not the free version. Then it can generate the image also. Yes. But it can generate a 3D image. But if you want the exact calculation, everything, that we need to develop in the CAD software. But it can only give it can give image to your imagination.
Yes, sir.
Yes, yes. Yeah. Any other questions? Any other questions?
Yes, sir. I think there are no questions. If there are any queries, we will share your mail ID so that they will be in touch with you, sir.
Yes, yes. Yes, sir. Thank you so
Sir,
much.
Venkat Konde, sir. Now we will proceed for vote of thanks, sir.
Sir, thank you, sir.
Yeah, thank you so much.
I'm honored to deliver the vote of thanks for this highly informative and engaging session. On behalf of ATAL FDP Organizing Committee, I extend my sincere gratitude to Sri R. Vikas Reddy Garu for sharing his valuable insight on basics of robotic programming, offline and online methods. Sir, your deep expertise in robotics, embedded system PCB design, and microcontroller programming has greatly enriched our understanding, and your discussion encourages to improve knowledge in robotics about robot operating system architecture and robot controllers and robot programming, offline and online methods, and motion and coordinated systems. So the knowledge is enriched with your examples, sir. And your session has certainly broadened our knowledge and provided clarity on real-world robotic programming methods. We are grateful to you for taking time out of your busy schedule to guide us today and for delivering such meaningful and impactful session. I would also like to thank all the participants for their active enthusiasm throughout the session, and also organizing team for their contribution and support for ensuring smooth conduction of this FDP. Once again, thank you, Vikas Reddy Garu, for enriching insightful session. Thank you, sir.
Thank you very much, sir. Once again, I thank everyone who attended this session. I hope the session was fruitful. If you have any queries, you can contact on my mail ID, ceo@robomong.ai. Thank you so much.
I have shared your mail ID also, sir, in the WhatsApp, in the chat.
Yes, yes. Thank you so much.
Thank you, sir. Thank you.
Thank you, sir. Thank you. Now you can leave, sir.
Thank you, sir.
Participants, if you have any queries, now you please let us know. And the link is it is activated. It is working only. You can please give your feedback and as well as attendance.
We are posting link in hyperlink format only. Please paste properly, sir. Already 250 members, they have given their feedback.
Sir, actually, I am unable to copy the link, sir, from chat box.
Okay.
So, can you help when I am?
Sir, that is a hyperlink format, sir. Just you click it, sir. It will be.
It will open, sir.
It will redirect
Sir,
to your platform.
I clicked in multiple times, sir. Even now, I am also trying. Multiple times, I am clicking.
Sir, we are providing in hyperlink format only, sir.
Now you touch, sir. Now you touch the link, sir.
Okay, no. Yes, I touched
it. Sir, you please touch it. I think you are having.
And share your screen, sir. We'll see, sir.
Okay, okay. I will share, sir. Sure. Okay.
Sir, share it in the hyperlink, sir. It is not opening.
Sir, we are sharing hyperlink only, sir.
Sir, I will share my screen, sir.
On computers, it is working, but not on mobile.
It's not shown in blue color, sir. If it is a hyperlink, it will be shown in blue color, no?
Sir, you are all logging in mobile, I think.
Sir. It is not showing in blue color. Mobile.
Sir, you are all logging in mobile now, sir.
Mobile, sir. Mobile.
In system it is showing in hyperlink only, sir.
I logged in mobile, sir. That's the main problem.
That's the problem. Just you copy it, sir. Link, copy and paste into Explorer or
Even
Google.
even that copy option is also not coming.
Sir, if raise any issues, just ping me in the WhatsApp personally, sir. I will share the link, sir.
Okay. I will share.
Sir, because sir, we need
Personally
to
ping.
get participants, sir. Because only 250 are attending and 450 are giving the feedback.
In
Just
youth,
giving
20
the feedback is
20
not
to
good,
40
sir.
members are seeing the live, sir.
It is not good, sir.
I will say.
Please. Govind sir, you can send us a WhatsApp message. No problem.
Okay.
And we won't put in the WhatsApp group, sir. It is not advisable.
Okay.
Also.
I will
Sir, if
personally
anybody
keep it.
facing any issue to prepare, fill the Google form, kindly personally ping to us. We will share the link, sir.
Okay. Thank you, sir. Thank you, sir.
Up to 9:30 we will share, sir. Later we will not.
Okay. I will.
Participants, any queries? Vikas, sir,
Yes, sir.
you are in
Yes.
line, Thank you very much, sir, Vikas, sir.
Thank you very much, sir. So
I will call you later, sir, personally.
okay. Can I exit, sir?
Yes, sir. Yes, sir. Yes, sir.
Thank you so much.
Sir, those who are logged in WhatsApp, I mean mobile, you please copy that link and you paste in the Google Chrome so that the link will get opened. Raghunath sir, you can send to this number, sir.
Sir, in mobile it is not copying, so that is the issue.
Yes, sir. Sir, you please send us personally so that we will send you.
Yes, sir.
No, not an issue.
Sir, for me also, I will send you personally.
Please, sir. Good night, sir. Please. No problem.
Thank you, sir. Good night.
Sir, now I am able to submit, sir. Submitted, sir.
Okay. Sir, it is active only, sir. We do not have any intention to trouble all the participants.
Only thing is 500 plus registered. Attending are only 300 members they are attending. Remaining 200 members simply they filling the attendance form. That's why we are not posting WhatsApp group, sir.
Okay, sir.